Why do monolithic database engines like sequence counters? Traditional database engines run in one location, hence the term monolithic. The entirety of their operation is contained in a single server. You mitigate risks like server failures by having a second server running in hot standby mode right next to the primary. This secondary server typically has a synced up copy of every insert and update. Or in some configurations, the primary and the backup are both reading off the same disk array. Whatever the configuration, they are both living close together. And all writes to that database are routed through whichever of these two servers is active. Why? It's the only way to guarantee that all inserts access the same monotonic sequence counter. Mirror copies of the database can be distributed around the world, but these mirror copies are traditionally only for reading. Any and all writes must be routed to the primary server at the central facility. Can you imagine if the primary server and all of its sequence counters were not at the same location? A replicated server 5,000 kilometers away wants to do an insert, but it must ensure it's getting a unique, never-before-used primary key value. Any increments done on this remote server would have to communicate with the primary. This ensures neither is dispensing an already used key. The latency cost of syncing a sequence counter between these two servers would defeat the point of having distributed primary database servers. Does requiring all routes go through a single primary server sound like a huge consequence for a simple sequence counter? Well, how else would you guarantee getting the next integer in a sequence? Or is there some other way you could provide a guaranteed unique key? Some sort of universally unique identification generator?